Hey, boys and girls, welcome back for part two. Well, here we go. So here it is. You can copy it off the PDF or copy it off here by pausing your video. Region R is defined as a region in the first quadrant enclosed by y equals radical x and y equals x divided by 3. Find the region of R. Find R when the base of the solid made up of circular cross-sections perpendicular to the y-axis. Find the volume of the solid if region R is revolved around the y-axis. And find the volume of the solid created if region R is revolved about the line x equals -2. Okay, so we're going to do all these together. Let's check it out. So first off, copy this down. That's like I did. Here you go. Okay, first gotta find the area of the region. So picture important, always important. So y equals radical x looks like this. Y equals radical x. Y equals x divided by 3, that's actually 1/3 x plus 0, you could say. So you start at the origin and you go up 1 over 3, up 1 over 3. So it kind of looks like that, right there. So it looks like it's this region right here. And so that's a top minus bottom one. And so we need to, it starts at 0, and we need to find this point right here. See if you can do it. Pause the video. What's this point? Let's see. Radical x equals x divided by 3. Let's square both sides. X equals x squared divided by 9. Cool. Let's times 9 on both sides. 9x equals x squared. Let's subtract 9x on both sides, because I think it's going to be some factoring. So we have 0 equals x squared minus 9x. Factor out an x. X minus 9, so 0 and 9, so 0 here, 9 here. Does that make sense? Radical 9 is 3. 9 divided by 3 is 3. Okay, cool, so that makes sense. So 0 and 9, that's what we got. Okay, so now the area is the integral, the area under the curve, between 0 and 9 of top, which is the curve, which is radical x, minus bottom, which is x divided by 3 dx. Of course, you can do that in terms of y, but we're going to do that for the next one, okay? So, here we go. R is the base of the solid made up of semicircular cross-sections perpendicular to the y-axis. Find the volume of the solid. Okay, picture, 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 na-na-na, so we can draw a little shorter version now, na-na-na, there we go. So this is 0, this is 9. And perpendicular to the y-axis is here. So coming out of here are all these semicircular cross-sections, like this. Okay? Infinite amount. So let's get a slice going. 3D it. Cool. This is going to be dy because now we're in terms of y, because we're doing this way. If we were going up and down, that would be with respect to x. But we're going from left to right, we're going horizontally, so that's in terms of y. So, in this case, if you flip it this way, this is the top, and this is the bottom. Okay? So the top is going to be this line, and the bottom is going to be the curve. So, this is also top minus bottom, if you recall. So the top, we got to find the inverse. So that would be y equals x divided by 3. We're going to solve this for x times 3, easy. 3y equals x. So 3y equals x right there. The next one, we have radical x equals y. So you just square both sides. X equals y squared. So x equals y squared is that one right there. So the top minus bottom is going to be the line 3y minus y squared, which is the bottom. Okay, so remember the volume of the slice is going to be pi r squared divided by 2, because this is a semicircle, that's the face, times dy. So that's going to be pi 3y minus y squared. But that's the diameter, so I need the radius, so that's going to be divided by 2 squared, and then I divide by 2 again because I have a semicircle. I'm dividing by 2 the first time because this is my radius, because I'm taking my diameter dividing by 2. Then I'm dividing the whole area of the circle divided by 2 because I have half a circle there. dy. Cool. So now the volume is the integral between 0 and, ooh, what's this point right here? On the y, that's what I need. So when x is 9, what is the y? So that would mean if I put x's, put it in any one of these, so this would be y equals x over 3. If you put in 9 here, you get 3. And square root of 9 is 3, so this is 3 on the y. Got it. So 0 and 3 of pi times 3y minus y squared over 2 squared divided by 2 dy. Or if you want to be fancy pants, it's pi over 8, 3y minus y squared, squared dy. If you want to know how you pi over 8, look at the previous videos. We did that before, okay, about simplifying this integrand. Cool. All right, let's keep it going. Nice job. 2 more. Part C. Okay, so we're going to take this thing right here. Same picture. So this is 9. This is 3. This is going to be 3y. And this is going to be y squared. X equals. Okay, now we're revolving around the y-axis. So here's the y-axis. So I'm going to draw a little. So this is the area we want. So here we got a mirror image. And so we're revolving like this. So outside to outside, inside to inside. Outside to outside, inside to inside, outside to outside, inside to inside, etc. Okay, so we have one slice. Let's get it going. So the area is on the right, so I'm starting on the right with my big R, and then I'm going to subtract my little r from there. So if I look this way, that would mean the top is the line, and the bottom is 3. So top is the line, the bottom is 3. So the bottom is just 0, is the axis, my bad. So it's a line, and then the axis. So the big R is going to be 3y minus 0, or just 3y. And the small r is going to be here to here, so that's going to be the curve to the axis. So that's going to be y squared minus 0. And this is dy. Cool. Okay, so now the volume of a slice is big circle minus small circle dy. And now the full volume is going to be between 0 and 3 of pi, if you want to do 9y squared, if you want to be fancy like that, or 9y squared pi, whatever, minus pi times y to the 4th. If you want to simplify that, that's cool too. If you leave it like that, it's fine. So there you go. No. Done. All right, last one. Pause the video, see if you can do it. Always pause the video for these ones, see if you got it. All right, here you go. Picture. Now you should be pretty good at drawing this picture. Here's 9. Here's 3. This is x equals 3y, and this is x equals y squared. Okay, so now we're revolving along the line x equals -2. Right here. X equals -2. So that means something like that. So here, and then here on the inside. So that would be 1, and then you just keep drawing them if you want. Sometimes it gets in the way when you draw a lot of them, but you gotta imagine that they're there, okay? There's an infinite amount. So, here we go. Boom. So we have, here's the original area here. So, this is the big R, and this is the small r. We're cutting out. So big R, turn it this way. Big R is going to be from the line to this line. This is the big radius right here. So that's going to be 3y minus -2. So 3y minus -2. The little r, little radius, is going to be the curve to the line y, x equals -2. So that's going to be the curve. Little r is going to be y squared minus -2. And then this is dy. And then last but not least, we can do the full volume. We don't have to do the slice if we're good at it. So 0 and 3 of pi times the big radius, which is 3y, minus -2, which is plus 2 squared, minus the small circle you have to cut out, y squared plus 2 squared, times the width of the infinite amount. There you go. dy. Got it. Cool. All right, so you have a couple problems to do. This is what I want you to do now. So you got scroll down, scroll down, scroll down, scroll down, scroll down, scroll down. These two right here. So find the volume of the solid generated when you revolve around the y-axis and the line x equals 2. Okay? Here are the answers. No, not here, my bad. Here are the answers right here. So see if you can get them. Ready, set, go. Nice job, everybody.